Okay, I'm just going to stop the transcription. Okay, I think we are good. Right, so let me share my whiteboard. Do let me know if you don't see it. All right, so here's the whiteboard. All right, so typical kind of problem that you would be presented with, and you must have seen that in the assignment. It's basically using probabilities and applying it to drawing without replacement. And a tree is just basically sketching the path of all possibilities. So let's say, for instance, right, you started off with red and blue marbles, okay? And for red, let me put the colors so you kind of makes it clear. You have 8 red marbles. Okay, that's what you start off with. You start with 8 red marbles. And then you start off with 10 blue marbles. So you got 8 red and 10 blue. That's what you start off with. So altogether, you're starting off with 18 marbles. Okay. You're starting off with 18 in total. Your total is 18. Okay. Now, let's say these marbles are in a bag. Okay. Now you can't see what's in the bag. All you have to do is you have to put your hand in it without looking, and you've got to pick a marble. Once you pick that marble, you can't put it back. All right. And you're going to do this twice. So in the end, you're only going to have 2 marbles, and you're going to draw these 2 marbles from the bag of 18, which consists of 8 which are red and 10 which are blue. All right, just make sure that everyone's following the problem here, and everyone can see the whiteboard. I don't see any messages in the chat. Okay, all good. All right, but yeah, just shout if you're confused or you want me to stop and explain something. All right, so here we go. We start off with 18 marbles. All right, now let's start drawing a marble. So we start off with a bag, and we start at this point, okay? We'll make a dark shade, this is where we start off. Now there's only 2 possibilities of colors. You can either draw red or you can draw blue. So let's say we'll use lines of color to kind of make it easier to color as well, right? So here, there's one option. I can draw red on my first try, or instead of drawing a red, I'll be drawing a blue. There's only 2 possibilities. All right, there's 2 possibilities. Now that is the first draw. There's only 2 possible outcomes. I can either draw red or a blue. Right, so I'll put a little dash line here. Let me just make it a bit. Okay, so put a dash line going down, and everything that happens before this is your first draw. This is your first draw. All right. Now, if you have 18 marbles, right, and 8 of them are red, then does everyone agree that your chance of getting a red marble is 8 out of 18? Okay, so if you have a total of 18 and only 8 are red, then your chance of getting a red marble is 8 divided by 18. So in other words, for drawing a red marble, it's going to be 8 out of 18. And I'm doing it for the red line, okay, because that means I'm drawing a red marble. And in a similar way, for the blue marble, the chance of getting a blue marble will be 10 out of 18, because you got 10 blue marbles. All right, let me stop there. Check the chat. Any questions? Everyone good? Can I get a thumbs up if everyone's following? So the first draw, that's your probabilities. And from what I gathered from the assignment, everyone's pretty much got that part. Right? Everyone seems to follow that part. It's in the second draw and onwards that I see complications. All right, so now let's move to the second draw. Okay, now remember, this is without replacement. Okay, so the question tells you you're drawing without replacement. So I'll make a note here to draw without replacement. And this is important because if you do not replace, then in your second draw, how many marbles do you have? If you made a draw in the first, well, if you drew a marble in the first draw, one marble, then how many marbles are you left in the second draw? Can you put that in the chat? Anyone take a guess? Doesn't matter if you get it wrong. It's worth taking a guess so I can see if everyone's following. Remember, you started off with 18, then you drew a marble. So how many are you left with? Everyone, yep, that's right, JD. 17. So everyone agrees that now, when we're talking about the second draw, which is everything now on the right of this dash line, we're now working with 17 marbles, not 18. This is your second row. All right. So now, remember, there's also just two possibilities once again. Okay. If you start off here, you can get a red again. You can draw a red again, or you can draw a blue. Oops. Get that there. Okay, now I'll draw the line. It's just replicating what you did in the first draw, but you're doing it again at each of these points. So now you can have the case where you drew a blue marble first, and now you're starting all over again. You have to pick again. So you can pick red. There. And you can draw a blue marble again. Like that. Okay. But now, remember, in the second draw, you are now dealing with 17 marbles. Let me just write this somewhere else. I've got some space. All right, so in total, you start off 18. Now, let's start working on the probabilities. So remember, now the probabilities for everything, every branch that you see, every line that you see, that is a possibility. All right, and each one of these must have a probability. So wherever you see a line, there must be a probability. All right, but all you need to know now is that these probabilities, the denominator, like you see here in the first draw, it's 18 here and it's 18 here. All right, so in the second draw, you should not have 18. The total now will be 17. Right, so let's go back here. This one, the total is going to be 17. We'll get to what the numerator is in a second. This one will also be 17. This one will also be 17. And then this will be 17. All right. So now we only have 17 marbles in the second draw. All right. Now let's follow this path here, the red and red. Okay, we'll follow this one here, going up red, draw red in the first draw, and now we're going to draw red in the second draw. All right. Now, if you look at this red line in the first draw, you have drawn a red marble in the first draw. Right? That's why the line is red. You have taken away a red marble from the pack. Now, if you only had 8 to start off with, and you drew one red marble already, according to this red line, then how many red marbles are you left in the second draw? What do you think it is? Remember, you started off with 8 red marbles. You drew a red marble. So how many red marbles are left in the pack or in the bag? Give it a try. Okay, just actually, the best way to do this is actually envision yourself physically doing that. Like actually taking a red marble out of the bag, placing it somewhere. And now, how many red marbles are you left with in order to draw a red marble? Does everyone agree that it's 7? Because you started off with 8. You started off with 8. you drew one red marble already. That's why this line here is red. It means you've taken away a red marble. So now you can only possibly get 7. So your chance of getting a red marble again is 7 out of 17. Okay, I hope you understand it, but if you don't give me feedback in the chat, then I'm just going to assume that you're following. Okay, now we're going to follow this part here. Now we're going red, and then we're going to go to the blue possibility. Now, this means that in the first row, you've taken a red marble. Now, in the second row, you want to know how many blue marbles do you have to draw. And the thing is, because you drew a red marble only in the first row, you are still left with 10 marbles. You haven't touched the blue marble, so you're still left with 10. So this should be 10. All right. Now let's follow this part here. Now we draw a red, now we drew a blue marble in the first row. We've taken away a blue marble. And here we are drawing a red marble in the second row. So the thing is, if you've only drawn a blue marble in the first row, you are still left with 8 red marbles in the second row. So that means this is 8 because you haven't removed a red marble. Because if you're following this part to here, it means you do a blue marble first, and then you're going to draw a red marble. And because you drew a blue marble first, there are still 8 red marbles in the pack. Now let's follow the last part. Going down here, we drew a blue marble first, and then we're going to draw blue again. Now the thing is, in the first row, we have removed a blue marble because you can see the line here is blue. You're following this part. So that means in the second row, you are left with 9 blue marbles. Okay, so now you've got all the probabilities you need in the second row. Everyone's good? Any questions? I'm assuming everyone's following. Okay, but just let me know otherwise. Okay, now that you've got the probabilities for all the events, you need to work out now the final probabilities. Because remember, you start off with a bag of 18, and the question tells you that you are making 2 draws and you're not replacing them. So in the end, you are going to be left with 2 marbles, one in the first row and then one in the second row. Okay, in the end, you're going to be left with 2 marbles. And so the possibilities, if you follow the paths of this tree, this first part right in the top, you're going to have a red in the first, so you're going to have a red in the first, and you're going to have a red in the second. Right? This means intersection. Right? So let me just draw it a bit neater. Here, this top branch that you're following is the probability of having a red in the first and then a red in the second. Right. And the next branch is you have a red in the first and then you have a blue in the second. This branch here, here, and here, this is the probability of having a blue in the first and a red in the second. Lastly, this is a blue in both cases. It's the probability of a blue and a blue again. All right, and now we just need to work these out given the probabilities in each part. And it's very easy to work this out. All you have to do is just follow the path and multiply both in the north. That means these 2 probabilities that you see here, you just multiply them out. Okay, if you multiply them out, then it's 8 over 18 times 7 over 17. Now, you must you either do 2 things. You either write the fraction in a simplified form. So it means, just for example, you can't leave the answer as 2 over 4. That's not simplified. It has to be 1 over 2. Okay, that's a simplified fraction. And the thing is, you don't even have to do like hectic math to try and simplify it. Your calculator does it for you. If you have the Casio calculator, right, for instance, and you must make sure it's in comp mode, not stat mode. If the Casio calculator is in comp mode, then you just need to press the fraction button, where you'd see the block on top and the block on the bottom. You press that and capture your number. So for instance, if you capture if you look at this fraction here that we're looking at here, right? What we're doing in the first one. On the top, just capture 8 times 7, and then in the bottom of the fraction, you're going to capture 18 times 17. And if you work this out in your calculator, it will simplify the answer for you. So there's no reason why you shouldn't give a simplified fraction. And a simplified fraction would be 28 over 153. Okay. Now, if you're not comfortable with giving the simplified fraction, then it's fine to just give the answer as a percentage or a decimal. So in other words, instead of leaving it as a fraction, you can write it as a percent or a decimal. I'll write it as a percent. Just so you have an idea, it's 18.3%. Okay, so that's your probability of having a red in the first and a red in the second. Let me go to the chat and see if there's any questions. Nothing. Okay, all right. And you follow the same procedure for each of these probabilities. So now we're on the second level. So we have a red first and a blue second. So you follow this path and you take the probabilities, which is 8 over 18 times 10 over 17. And that will give you 40 over 153. The next one will be the same value. If you follow the path, it's 10 over 18. Oops, not that. 10 over 18 times 8 over 17. And that'll give you 40 over 153. Okay, and then lastly, it's 10 over 18 times 9 over 17. And that gives you 5 over 17. All right, everyone follows that? That's your probability tree. Does that make sense? Any questions, people? Okay. Okay, just in case some of you are wondering, why do we multiply them? So for instance here, why is it that we multiply them? Right? Some of you may ask, why do you multiply them? So let me just create a new whiteboard to explain why. All right, let's say you start off with, I'm going to keep it simple so I can show you all possibilities, right? Let's say we just have 3 marbles. So I'll draw it one here, here, and here. We just have 3 marbles. They can all be the same color. I don't really care. I'll just shade them like roughly blue and blue, right? But even though they're blue, they are distinct marbles, okay? So we'll label them. I'll give them a label. This one is marble 1, this is marble 2, and this is marble 3. All right. Now, if you make 2 draws, okay, you draw twice, and you don't replace, right? So there's the one possibility, right? So I'll make 2 columns here. Yeah, this is your first draw, and then this is your second draw. So the one possibility is you could have marble 1 in your first draw, then you could have marble 2 in your second draw. And the next possibility is you could have marble 1 in the first draw, and you could have marble 3 in the second draw. Then next possibility is 3. You could have 2 in your first draw, and you could have 3 in the second draw. All right. Another possibility is you could have drawn second one in your first. Oh, sorry. Hit the stylus. Could have 2 in the first row and then 1 in the second row. Option 5, you could have 3 in the first row and then 1 in the second row. And then the last possibility is you have 3 in the first row and then 2 in the second. These are all the possibilities. To get these 3 were pretty simple. All you gotta do is just reverse what you see in these 3. Reverse the order, right? But you'll notice how many possibilities are there. There are 6 possibilities, all right? Now, probabilities are basically working out what is the chance of something happening over all possible outcomes, right? If you notice this, right, they have 3 marbles, right? There's 3 marbles. So in the first row, you start off with 3 marbles. That's the first row. In the second row, because you don't replace them, you will have to 2. This is your second row, right? So that if you wanted to know how many possible outcomes there are, all you need to do is multiply these 2 numbers, 3 times 2, and that's how you get 6. That's how you get 6 possible outcomes. So if there are 3 possible ways of doing one thing and 2 possible ways of doing another thing, then the total number of possible ways is 3 times 2. And that applies to anything, okay? If there's 10 possibilities of doing one thing and there's 20 possibilities of doing another thing, altogether there's 10 times 20, all right? Possible ways. So in the exact same way here, instead of having 3 marbles, we start off with 18 marbles. And then in the second row, we have 17. So that means in the first row, let me just put up the column here. In the first row, you have 18. In the second row, you have 17. So altogether, there are 18 times 17 possible outcomes, which is why you see here, look at the denominator. That's your possible outcome. It's 18 times 17. Now, if you understand that logic for the denominator, the same thing applies for the numerator, where we're only looking at how many possible ways can we get the red marbles. That's how you have the 8 times 7 as well. Whatever you do to the denominator, you do to the numerator. Okay, does that make sense, everyone? People? All good? Thanks, Michael. All right, I'm assuming everyone's following. There's something you would have noticed here. If you didn't, I'll point it out. These are all the possible outcomes you can have. That means you can only have this outcome, you can have this one, which is the second possibility, this is the third possibility, and this is the fourth possibility. There are only 4 possible outcomes. And that means, and you would have learned this terminology when you were studying probabilities, this is known as a collective exhaustive set of events. That means these are all the possible outcomes. Right? There's nothing else that could happen that we haven't listed. Everything that could happen has been listed. So this is a collective exhaustive set of events. And that's just a fancy way of saying that if you add up all these probabilities, these 4 probabilities, they must equal to 100%. So if you add them up, you'll get a total of 100% because that is all the possible outcomes that are available. All right? Now, the question is, let's say they ask you, what is the probability of getting 2 different color marbles? What's the chance of getting 2 different color marbles? So what's the probability, the chance of having 2 different colored marbles? All right, now if you look at all the possible outcomes, this doesn't classify as 2 different colors because it's red and red, it's the same color. This does not classify as 2 different colors because it's the same color, blue and blue. So it's only these 2 where you have different colors. There's 2 possible outcomes. All right. So remember what I said, when you add them all up, they're 100%. So in other words, if you had to work with the chance of having 2 different colored outcomes, you would have to add these 2 probabilities up. And that's your answer. all right? And the two possible probabilities, this and this. In other words, your answer would be, instead of just saying this plus this, I'll just say 2 times. That's because they're the same value. Okay, they're both 40 over 153. So the answer is 2 times 40 over 153. That's the answer. And if you work it out, I'll put it as a percent for you. It's 52.29%. That's your answer. Okay. Okay, so that's probability trees. I hope you understand this. Are there any questions on it? All good? Anything is unclear? Remember, your tree must reflect all possible outcomes, and each branch of those trees must have a probability to it. This pointer, these probabilities in the branches. So if you look at what I've done here, this 8 over 18, it's not simplified, okay? And that's fine. If these intermediate probabilities are not simplified, it's fine. But what must be simplified are the final probabilities. These must be simplified, right? So if my takeaway from this is show your branches. So for instance, I'm showing you a red and a red. So I'm telling you that that's a red by color. If you don't want to use color, then you need to say it's red. This is the red branch. Okay, if you're not doing different colors, if you're drawing all with black lines, you need to show the examiner that this is, you're drawing red by just writing R there, write a R there, write a blue here, B for blue, red here, B there, and the same here. Okay, because we don't know what event you're allocating the probabilities for. So you need to show us that, right? So you don't have to simplify the intermediate probabilities. The final ones you do. Or you can write it as a percent. All right. And you must show the tree like how I have done it here. So when you've shown all these possibilities, at the end of it, like what I've done here, show the workings like what I've done here, and list the final probability. All right. Okay, everyone, that is it from my side. And that's all I wanted to cover this evening. Okay, I'm not sure if you started revision, but I hope you have. Sure, work through the problems I've set for you. I mean, if you look at the announcements, I've given you revision exercises to try out, and do try the practice test I made available. All right, but if you don't have any questions now, it's fine. Please feel free to drop me an email with anything that you're uncertain about. All right, that is it for me, and we'll chat soon. Thanks, everyone.